disc magnets are one of the most popular items that we sell on our website. Disc magnets, large diameter, and the diameter basically is greater than the thickness. Whenever the thickness or the third dimension gets longer than the cross section here, we call it a cylinder magnet. But in this case, I want to show you some of the features of disc magnets you want to look for as you're going through to help you understand this. This is a very large 5-inch diameter, 1/4 inch thick disc magnet. We have had disc magnets as large as 8 inches in diameter and up to 1/2 inch thick. This is I've had these 5-inch ones. I also had these in 1-inch thick ring disc magnets. So these are very powerful. This is an N50 magnet. This is a 2-inch diameter, 1-inch thick N50. We have disc magnets all the way down to roughly 1/2 millimeter in diameter by 0.25, 0.3 millimeters thick. This is extremely tiny. It is even smaller than the period on a printed page when you're looking at where a period would be from a typesetter in a magazine or something. And so they're very, very different sizes. They also behave differently. One of the things that I wanted to make sure we understand, because sometimes people get confused, they assume that because this is a large diameter disc magnet, that it is the exact same magnetic force all the way across the magnet. And it's really not, because in the center, it is much weaker. What's happening, you can see how this magnet is showing us the lines of flux. And the lines of flux are pretty much perpendicular as you get to the edge, as you get to the center. But as you start to move to the edge, the flux is trying to wrap around the other side of the magnet because the North Pole is trying to find the South Pole. And it intensifies the field strength near the edge of a large, thin disc. So as this moves close to the edge, it'll take off and run to the edge because it's running to the stronger field. And as it encounters a stronger field, it goes to the next stronger and the next stronger until it ends up at the edge. That's what you will see. If we put a piece of plastic over it to help us see it a little better, you can see that out at this point, it is all the way laying down. That tells us what the flux lines look at that, how they look at that point. Now let's take the larger 2-inch diameter, 1-inch thick magnet, and when we do the same process with it, you see it stays pretty much in the center. As I move it around, it tilts, but nowhere near as much of an angle as the 5 by 1/4 does. Now we're going to look at another feature of disc magnets. You want to make sure that you notice the direction of magnetization. This, where they stack up like this, one magnet on top of the other, is what we call magnetized through the thickness. This dimension, the third dimension, is the thickness. We're using the XY dimension to define the circle. That would be its diameter, 1/2 inch diameter by 1/8 inch thick. This magnet is magnetized through the thickness. We also have disc magnets magnetized across the diameter, and they stick together like this. They will actually stick like this, but it's a very weak hold because they're only sticking at the edges, and you can straighten them back out. And this is something that we have a number of customers who need this. These work out very, very well for people who use them in a rotary application where they're mounted on a shaft and they go round and around, and they use a little Hall sensor to detect the presence of a magnetic field. And so as the Hall sensor detects it, it's able to give them the RPM, or how many times this is turning per minute, by just mounting one of these on the end of a shaft. So we do have an application for it. Watch when you're ordering and make sure, do you need it like this, that's magnetized across the diameter, or do you need it like this, magnetized through the thickness? Another feature that we do with our disc magnets is we have a couple of sizes that have peel and stick adhesive on them. And just as it says, it's peel, and you have a 3M adhesive on one side. Now, if you're looking for an application where you're going to use a peel and stick, you may want to notice, if you're going to use peeling stick and on the other side a piece of metal, then it doesn't matter which polarity you get in the peel and stick. If you're wanting it to be an application where two magnets stick together and you want adhesive on the back side, you have to get some of the magnets North Pole and some of the magnets South Pole. And that way they will stick face to face where the adhesive is holding them. Your best application for that is to not use two magnets, but to use one magnet and a piece of metal, and then you don't have to worry about the polarity. Hopefully this gives you a little bit of insight about our disc magnets, and if you have any other questions, we'll be happy to answer them.